Let's explore solving an inequality algebraically. Let's take this inequality. Let's find its solution set. Let's rewrite this inequality so that one side equals 0. So we have this equivalent inequality. What is its solution set? Let's look at the function defined by this expression, or this formula, x cubed minus x squared minus 6x. So when is this true? So of course, if we had its graph, the graph of this function, we could see easily the points that correspond to f of x greater than 0. So let's do this algebraically. Find the solution set algebraically. Let's see where f of x equals 0. So let's factor the left-hand side. It has the greatest common factor of x, which we factor out. And then the trinomial in parentheses factors as x minus 3 times x plus 2. So the solutions are 0, 3, and minus 2. Let's draw a number line. Let's plot these points where f of x equals 0. We also see that this inequality is defined for every value of x. If there were some values of x for which the inequality were not defined, we would also plot those. So we have these 3 points, these 3 numbers plotted, and we want to make this important remark. So here we have a polynomial function, but this is also true for rational functions, that if f of x1 is positive, and f of x2, some other input is negative, two inputs have different signs for their outputs, then somewhere in between, the output is 0. X prime between x1 and x2 with the output of x prime being 0. Or x prime is not in the domain. Let's see how this important fact helps us here. So we have broken the number line into 4 intervals. Let me write up these intervals vertically. And in this column, we're going to pick a number, call it alpha, in the interval. So it doesn't matter what number you pick. I will, in this first one, I will pick -3, and then -1 here, 2 and 5. And what we want to look for is the sign, positive versus negative, of f of alpha, the output. see, what is f of negative 3? Let's use this expression for f of x. So this is equal to negative 3 times negative 6 times negative 1, which is, its exact value is negative 18. And what I care about is that it's negative. So we see that we have a point, negative 3, and f of negative 3 was less than 0. So this tells us, by this important note up here, that f of x is less than 0 on this whole interval. If it were ever positive at some point, then there would be a point in between that point and negative 3 at which the output was 0 or not defined. But 2, negative 2, 0, and 3 are the only points at which the function is 0 or not defined. So between consecutive points that are plotted here, the function is either all positive or all negative. So let's do this next interval. Let's plug in -1, and all I care about is the sign of the output. So the expression for f of x is written as this product right here with 3 factors. So the first factor is negative. The second factor is negative. And this next factor is positive. So this is a positive output. The only thing that we need to worry about is the sign of the output. When we plug in 2, we get positive times a negative times a positive is a negative. F of 4, f of 5, which you could use for any point in the open interval. We get out positive times positive times a positive, positive. So this tells us that f of x is greater than 0 on this interval union this one, and f of x is less than 0 on this interval union this one.